Presentation tonight. It's all about visualizing data, visualizing projects using Revit and related tools, some other parallel tools. And we have two great speakers. I'll introduce them in just a second. Let's just go through some of the housekeeping stuff. We have four great sponsors. It's the four major resellers in the Metro, New York, and beyond area. Imagine it, Microsoft, Microdesk, and Consulting for Architects. They work really hard to support us, so we appreciate it. And we'll talk a bit about tonight's sponsor in a second. Pratt University provides a space for free, and it's Karen Miletsky, who runs the Center for Continuing and Professional Studies. Sometimes Karen's here to say hello, maybe that's tonight. But Pratt has a lot of related Revit and other programs if anyone's interested. AI credits. We try to get AI credits. Not all of our programs qualify, only about a third or half do. And Aaron Gonzalez, who is in the back there with the bow tie. You think we'll get it for this time? Okay. So Aaron coordinates that, and the folks at Bradford Construction actually are the sponsors of it because it costs a lot of money to be a provider, credit provider. So Aaron handles all that. Thank you. Webcast, meetup.com, provided by SOM, and the liability insurance that we need to have for the university, provided by CASE. And then a bunch of other big and small support is provided by ARCAD, the folks at Exomic who make Open Asset, BIM, Open Asset Image. Advanced 2000 has been a great sponsor. They've been providing us with high-end virtual workstations in the cloud. We haven't had the opportunity to leverage them except for one time a few months ago, but we keep meaning to. Just it's a bit crazy getting everything set up on our end. And in my firm, Array Architects provides a lot of support. Tonight's sponsor for the food and overall is Microdesk. We have a few people here from Microdesk. Of course, they're in the dark, so you can't see them. So wave if you're back there. They have their Our Solutions, Your Success campaign, a great partner here in Metro New York, East Coast, West Coast, BIM implementation, enterprise strategy, technology management, and application development. And, if you don't know any of the folks there, definitely reach out to them. They're great to work with. And thank you for your support. And thank you for getting on the phone and getting the pizzas here. I know that took a little extra effort. So these are the all of the volunteers that help keep the group running. Believe it or not, these little meetings that can take a little bit of effort. It's mostly getting the speakers to actually say yes to a date and actually get their slides ready, that kind of thing. Not do it the afternoon before. Is that what I heard earlier? So tonight's speakers are actually also our vice presidents, Jason and Alfred, and I'll introduce them in more detail in a second. I think I saw Snigda. Is she here? No? No, okay, maybe not. Ian is here. Ian is our online user experience manager to make sure that people online can actually hear stuff. He's actually been videotaping it. So the recording, we record it with GoToMeeting and we share the recording of the audio and the presentation. And Ian has been recording the live stuff and we're experimenting with improving that. So thank you for doing that. And I introduce you to Aaron and Bob Urey. Bob is in the back somewhere. There he is. So Bob is here always for more support. Thank you. So next month is Mike McKeon from CASE. He's going to be talking about Revit and Celibri. Celibri is a great rule-based model analysis software. In addition to clash detection, there's all sorts of rule-based stuff. In the future, we'll be seeing lots of need for this to way beyond clash detection. The whole AutoCodes effort to codify the building code into rules that could then be applied to models is in the works by the folks at Fiatech and a bunch of other big sponsors. Tools like Celibri can help us actually do things like that. So definitely don't miss the Celibri talk next month. January, February, March, and beyond. In the works, we have some verbal yeses from folks from Turner Construction, Harry Madison, formerly of the Revit team, the Revit API, and a bunch of other things. Paul Aubin, who is a BIM consultant from Chicago. He just released his, was it Revit Renaissance book, Classical BIM. He'll be here trying to figure out when, maybe March or April, to talk about using Revit in general, but also to how to apply it to forms that aren't quite as direct. And what am I forgetting? I don't know. Someone else who said a verbal yes. I don't remember. I'm forgetting someone. So those things in the works. We'll start posting it. Try to actually post it more than a week before. We try to do it a month or two before. It's been a little crazy. We'll get to that. Okay, our speakers. Alfred, formerly of SOM, now of his own practice, MAP. Great architect and deep Revit BIM knowledge. Goes way back. He worked on Tower 1, the Freedom Tower, in Revit, and he worked on a bunch of other iconic buildings around the world for SOM, and now has a small partnership here in the city working on various projects and BIM consulting as well. So we'll be talking a bit, and then there's Jason Chen, also a former colleague at SOM. Jason's still there, senior BIM manager, digital design manager at SOM, and the two of them should be a great powerhouse combination of BIM and Revit knowledge. So please join me in welcoming them to the user group. Oh, by the way, the sign-in sheet, I'll pass it around. Sorry, turn it over here.
Hey. So when Robert asked me to do a presentation a few months back, I think the committee was searching for a topic that focused on how the average Revit user who might not have access to teams of specialists and how they might be able to get more out of the Revit model. And from our shared time at SOM, he knew that I had always approached the Revit model from a different perspective and played around with rendering even when rendering was considered really crazy to do from Revit. And my experiments had some success, and but I just sort of had them sitting around and I never really presented them. So this is going to be the first time I'm going to sort of sort them together and mold them into some sort of presentation. So, but before I get to the visuals, I'm going to quickly run through my philosophy and my approach to Revit, and to give you a better background about why I approach it the way I do. So I think a lot of Revit dialogue today focuses on how complex the project is and how BIM can potentially streamline the process through clash detection, interference checking, etc. But Revit is usually seen as a documentation platform, and for the output of calculations, and oftentimes the renderings are generated by third-party software. So I think some would agree that this kind of frames Revit into a tool for the technical architect, or only as a documentation tool. So therefore you get people complaining that, well, you can't design with Revit, it's too stiff, and therefore the designers and our architects tend to move away to other platforms and platforms like Rhino, 3D Max, Maya to do design. And we begin to have firms also developing attitudes that classify Revit work as just documentation. Like for the 2 weeks before deadline, everyone pens down, catch up to the latest design scheme, sort of mad scramble to make sense of months of design work. The BIM model becomes more like a liability and contract requirements, not really a tool to forward the design, because the designers are pushing the project forward and they're investing time in the model. They invest their time, effort, and time in other models that produce the renderings and options that sell the project and appeal to the client. So I think it's this gap in the design process and the technical documentation process, which is oftentimes frustrating the implementation of BIM. And you can see from this simple diagram that it fragments the process, it begins to fragment the team, and it fragments the responsibilities. So I kind of set out to tackle this problem when I was in SLM, to try to reach this ideal goal of one. For me to just build one model to do basically everything. And it was a pretty ambitious goal at the time, and I think it remains like a central motivation for me in terms of how I like to approach my Revit model. So I think the best way to communicate my result is still to distill them into some sort of best practice in approaching Revit. So I'm going to list a few of these best practices that I tend to follow and I sort of come up with through the years. That one, the model should reflect the current state of design development. That often people model more than what is really necessary for the phase of design. And it's really easy to model too much. And I think too much building is, when you think too much about building just the right thing further down the line, that you sort of make the model really heavy and bogging down the design process. And I think the model should always should serve the function of the model. This leads to my second point, which is that the model should stay nimble. If you're in schematic design, the model should be light, changeable, flexible, quick, because it's in the design phase. You don't need to worry about stairs or elevators even, just use 2D elements. It's easy for Revit to become so technical that it really takes some effort to keep the model flexible and capable of servicing the process. So the model, I think, should serve the team shouldn't be serving the model. The model is a learning platform. And if you keep things nimble, it's easier for people to understand the model and experiment. They're more willing to try out new tools, invest their time, and because they feel they can yield immediate return. And finally,
Alfred, I think something's messed up the microphones. Let me just double check it. This is on.
Maybe I need to be closer.
Can you hear that again?
No.
That is. That's off. How about that? Can you hear us now, Ian? Okay. We lost a few minutes there. Sorry about that. Keep going. Thank you.
Okay. Sorry. Then model as a shared responsibility. Because everyone's invested in the model, it's really important to be sure that the level of traceability is maintained. And what I mean by that is that anyone in the team can with reasonable knowledge about Revit can figure out how something was built. And it's about the cohesiveness of the team to be more transparent and to communicate, to resist the sort of personalization of the model. I really believe that like a cohesive team can be an extremely productive team because of Revit. And team size and project size is no longer directly related. And finally, I always say we should demand more from the model. Too often we forget that we're investing our efforts into a smart model. And maybe if we demand more from our Revit models, users will be more motivated to innovate the existing tools, develop clever solutions without 3D party tools sometimes, and push the model to new heights and new sophistication. So I'm going to start off by talking about a few projects that I worked on when I was in Skid Row and Maryland, which is some of the times when a lot of these things, these philosophies came together. So let's start off with the Zulik building, which was, this was actually done on Revit 2008 and 2009. The project was designed in 2008, recently was finished in 2012, last year. So this is what the building looks like. These are completed photos. It's a 34-story commercial tower by SOM. The challenge at the time was it was a 6-month fast-track design project with a very small staff, approximately 5 people. We had to go from concept design to design development in 6 months. So we didn't have the model to, we didn't have the manpower to build a separate rendering models. So we decided that the Revit model was going to be both our design model and the documentation model. And we were actually trying to lead mainly with the design model, using Revit as our design and rendering model. And the plan was that when we entered the documentation phase, that we might just flip the switch, going from coarse to medium setting and fine setting, and we'll have our design development set like 75–85% complete, and coordinated with the design intent. So, just going through a few sort of examples of so you can familiarize yourself with the project site. It's the form of the building is basically 2 split massing that address the intersection. Pretty simple. It's in the Philippines, really hot, so we were aiming for LEED Gold, and our building is entirely wrapped in glass. So our engineers mapped the solar heat gain onto our curtain wall. But this was not done in Revit, this was at the time done in Ecotech. And we unwrapped the map to figure out where we needed more frit pattern to shade the building. And then we arrived at a bamboo themed idea for our frit patterns for our design inspiration. Then the Ecotech map helped was laid over their curtain wall surface areas and to figure out the density. Then what we did, and this is now in Revit, we've documented 9 panel types of Revit curtain wall panels that were basically arranged on piece by piece onto the curtain wall. And at that time, we had a team in India that helped us basically do this overnight. The panels were therefore scheduled and tagged, and from then on, we were able to manage in all the frits, all the panels, from just the Revit library, the family library, just managing 9 panels. And also at the time we also did some, as we were doing studies of the model, the curtain wall was built as a separate link model, and we were able to do our studies on the side and also basically just switch out the curtain wall system whenever we thought the design scheme was good enough to move forward. So now, basically at the time we were also experimenting with how to do renderings, and I don't think anybody had tried that at SLM at the time, so this was some of the early steps and the early results from that. We basically here, what we were doing was we were looking at we started wrapping the building with one single panel. So each surface was one large wall panel. And we were looking at the tool in Revit from the material where you could basically play with the mapping the black and white map. So it basically allows the material to be cut out during the rendering process. And then the next step beyond that was to start to sandwich that wall and make that wall into basically like a real curtain wall with layers. So you can see how progressively we were improving that. And what you see here is the result of a rendering. Everything here was rendered in Revit, and the only thing I think that was photoshopped here was just the blurring of the cars down there. And this is the final building when it's built. So we think that we were pretty close in our Revit rendering at the time. And this is another view. This is the view of the completed building. This is a view of the lobby entrance. So you can see how we modeled everything. We modeled all the fittings. And this is all during the design process as part of our rendering model. because we needed to present to the client. So we weren't really even thinking about the documentation process yet. This was just, we needed this to show the client. We even experimented with lighting. As we were putting the lighting fixtures in, we got the ICS files from our lighting engineers and put them in and played around with the lighting. More lobby and typical floor space rendering. We modeled everything like you see here. We also have the mecha shades. And this is an example of sort of a corner detail as we were basically finessing the corners and the details. You can see how each panel also had the fit patterns on it. So this is when the large panel was turned off and we were just displaying the corner. Just typical floor layout. This allowed us to basically also take a lot of views inside for our client. So almost every page of our design document had a 3D view. We put this to help explain to people out in the Philippines, our executive architects there, to all the materials. We put that, you can see, in every sheet. And of course, the process in the end was that we had to tag all the materials. And because we were already rendering and managing our material library, that was actually a pretty fast process. We tagged everything, and that was all scheduled right away. As you know, like in a lot of these documents, you have the nomenclatures, STO1, RAMP, the metals. Those numbers change toward the end of deadline, and usually people have them as a separate Excel chart, and it becomes a real mess because you have to chase down all the numbers. For us, it was all part of the schedule, so we actually were just managing the numbers here, and everything in the model was automatically updated. So that was sort of an example of a process where we were using the design model as our sort of the lead, and the documentation process was kind of a resultant of that design, and we thought it was pretty successful. And then, since then I've developed a little bit more, methods in terms of visualization in Revit. This is a project in Busan that's on my design, and you can see on the right side we have it's a lobby rendering that I did. And by that time I've already figured out a lot more about rendering. But here, the special thing here is about the video. So I'm gonna, 1 minute. So this is 2 videos that came out of this lobby. We were able to export. We have so you can see sort of part of the rendering process as well. We build a lot of the details in. I feel that a lot of what makes a rendering or visualization shine is some of it is in the detail. And that automatically just works in our documentation process. And I think just generating this didn't take very long. I think it was only maybe 15 minutes. There's another view. And this was all done at the time of Revit 2008, Revit 2009. Go back that, sorry. Okay. So, World Trade Center, I don't know if you guys know that, World Trade Center was actually built in Revit. And this was, we started at the time in 2004, and that was the first version, and there was a second version. But there was a lot of development in Revit tools. And the documentation process, you can see here, I'm just taking a couple of views from it. We went into a lot of detail. I was responsible for all the public spaces, so you can see how we went and modeled everything from you see here, even in the exit signs and the wayfinding. It was all in our documents in Revit. And later on, when we needed to update some of our renderings, we actually took advantage of the Revit model. And this was a design study we used at the time. This was you see here, there's the left image was from Revit. The right image was the original image from D-Box. So that designed during the concept design phase. So we think we've come pretty far in terms of being able to develop our Revit models to sort of begin to output something close in quality to that. But I think it's still not quite there yet, but this is back in 2000. And now, it's, I'm going to show a few things just quickly of what I've worked on in terms of, since I started my own practice, some visualization things, techniques. Like I've always said that there's other ways of doing renderings, and there's always, with Revit, you have the advantage of, taking one camera and having different ways of displaying things. So here you have a rendering of a project. This is the Dulles International Airport expansion work where everything was coordinated in Revit below grade, and I was tasked sometimes with creating some of the visualizations. So here was an example of the wireframe and hidden line view overlaid on top of our rendering. Another stylized thing where I consulted to work on the Deloitte Toronto office renovation and fit out. And again, it's a combination here of hidden lines, the shaded view, and the rendering, all just overlaid on top of one another in Photoshop. Here's another one of a house that I had designed with, the internal rendering of lighting. Here's the interior of that. The Photoshop elements here, like the landscape backdrop and the marble pattern. This is another project where you see on the left the existing site and the Photoshop, which Photoshopped in the Revit rendering, and that was done where we had basically everything came out of Revit the way it is, except we had to reinforce some of the joint lines on the facade. So that was actually, I think, hidden line that was tweaked a little bit in Photoshop. And I think the most difficult part here was actually matching the camera to the perspective. And there's another example of an existing site And here, it's actually not a rendering, it's all basically just shaded view. Very quick. And that's it for me. And we have Jason's gonna do the second part.
So like Alfred was saying before, like we have this awesome Revit model. We want to take more out of it than just documentation. So unlike sort of office experience, usually when I'm brought on a project, I'm sort of already in DD. So it is more about documentation than the visuals. So I'm just gonna go through some parts that I did and some sort of rendering sort of best practices. So here's some content I'm going through. Sort of rendering in Revit, sort of rendering from Revit, and then sort of beyond pictures. So first off, rendering in Revit. So just a quick, how to get started. Run down, you pick your view, you set up your shadows, you set up the lighting. You always perform a draft rendering first before you do your final rendering. And then you set up the size and resolution, and then you do your final rendering. It's a very simple task, just a lot of repeating sort of at the bottom. For those who are not familiar with Revit, some of the dialog boxes, there are some of the important things to make sure you check off is shadows, you have the right lighting for your scene, and whether or not you want to use a sky background or a photo that you have of the site. Here's the rendering dialog box really quickly. One of the most important things here is set the quality of your, so where's this draft, setting the resolution of the rendering that can really determine the length of the rendering and sort of what final product you get. And also, if you do select the Revit sky backgrounds, here it has some additional settings here. Determine how many clouds you have, is it hazy or clear day? So, some options. If you are doing a interior rendering with sunlight, there's something to just make sure you check off that you turn on all sort of daylight portals, otherwise the sun won't penetrate through your curtain wall or your windows or anything, glass materials in the exterior. And if you're doing scenes with artificial scenes, it's good to group your lights into sort of areas where you're doing your rendering. So what happens if all your lights are on in your rendering, a single room, Revit will try to figure out all the lights in the entire model. So you want to limit sort of what gets turned on, what gets turned off. And after you've done the rendering, there's some post-production work you can do on that rendering. And the one I mostly use is the exposure value. The renderings from Revit tend to be a little bit dark, so I always sort of punch up the brightness a little bit. Some tips. Your crop size of your view is very important. So in Revit, everyone knows sort of camera's not the best camera tool. They sort of said 1 field of view, and that's pretty much it. But if you select the crop region, it basically tells you what print size is, and that helps you determine the size of your rendering. So that's where use a section box to limit the scope of the rendering. That's greatly speed up your rendering times. I always do a draft rendering at medium quality. That will get artificial lights, suns, to get sort of more approximate lighting than when you get in the final rendering. Always use appropriate quality settings. Try not to go above the best setting in Revit. Just beyond that, rendering times increase exponentially. So, and again, limit the number of artificial lights you have on. So I'm going to do a couple of case studies that I worked on. This is an office tower in India, and when I was brought on the project had just finished SD, and here we see a rendering from 3D Max. They brought me on mainly to sort of set the Revit project, but also to be the main person doing the documentation for the enclosure of the system. So here's a rendering of the exterior enclosure that I did. That was my main focus. And through this process, my main goal was to produce drawings from the Revit model. So, like Alfred, I want to do the model really well, so that I do it once and I get multiple products from it. So I get elevations, I get partial elevations, partial sections, partial details, and you'll see some 3D details as well. I worked as a project, so I built the model once in the right way to get multiple end products. So here's just a quick review of the building geometry. So after I saw the geometry of the building, I decided to use the in-house Revit kernel wall system. It's not very complex geometry, so I used the kernel wall panel and molding system. So here's the kernel wall, and there's actually two kernel walls on top of each other. So this is the first kernel wall, which controls the panels, which is all the sort of glass and shading fins. The second wall was mainly for the frame. Now, initially I used the molding system in Revit, and it worked very well until they wanted to see joints. When you add joints, unfortunately, the molding tool in Revit is just a profile that sweeps across the line, so you can't really break it up any more than that. So that's when I had to develop a second kernel wall that was just the frame itself. So here's a kernel wall in completion. Here's one wall that's just the frame, and here's another wall that contains just the panels. Now the frame wall is basically composed of those pieces on the right. So we have 90-degree corners, we have 45-degree corners, we have some straight T-points. So out of these kit parts, I was able to build the entire frame system of the building. And for the panel, the system is made out of glass, vertical molding, shading fins, and shading fin supports. So I went a little overboard with shading fin supports. In every section I cut, they always ask what's holding the shading fin. So instead of redrawing two lines, I decided just to have it all modeled in. It didn't add too much weight to the model. So here's a shot of the Revit model, and here's a shot of the render. The building is all white; it's not just the white material typical render we see. Some other renderings. Now, I did use this tool as a design tool for the extra enclosure since it was only developed and designed to SD. And when we moved to DD, the entire team moved to Revit. But since I was doing the enclosure, I was not really familiar with sort of Rhino. So any sort of design change in the work was done in Revit and then rendered out from Revit. Elevation shots. So close up the kernel wall. So you can see there's sort of quite a bit of detail added in for the joints, the stack joints, all the shading fins and supports themselves. There's a corner detail. It's a close up of the typical panel. Now this kernel wall, this typical bay has 6 panels, but throughout the project, you vary between 4 and 8 panels. So the family's built in such a way where it can array itself out. So I don't have to build one panel for the entire building. There's a front elevation shot of the entrance, side shot. Now from this model, since I had this model already and I was mainly responsible for the enclosure, I did take some liberties on the inside just to try to get more out of the model than what I was already getting. And so I did some interior, lobby, renderings, play around with some night shots, and sort of did perspective section cut. So I'm showing some MEP systems and how the core is arranged. In this case study, there's a tower that I'm working on right now. It's a complex project, so just leave that tower. Here's a building geometry of it. It starts out as a rectangular base with rounded corners. As it gets towards about a third of the way up the building, it gets a bit of a belly, and then towards the top, it sort of tapers all the way back. So, not the simplest building to build a Revit. So in this case, I did not use the typical kernel wall system in Revit. I had to use adaptive components. So here is a corner of that kernel wall. There are 2 main components to it. There's rectangle panels that either have a trapezoidal shape or they slope in and out in the Z direction. Then we have a cylindrical panel that also slopes in and out as well. So here are the panel types I developed for the project. On the left, you see there's a 4-point adaptive component for the rectangular shape that can then be flexed in and out in either direction, and then a 6-point panel system, which is cylindrical panel. So I started out with Revit mass, took the lines from Rhino, they gave me the profiles, I extruded the mass up, I divided the surfaces of the mass, and then I panelized it. Now this this did take some time because not all the panels are the same. So I divided the mass in such a way where the panels that were the same were one mass that I divided the surface of easily just repeat my pattern across. There's a shot of tower. Here's a render of the tower. Close-up shots of it. So this current wall, where the build is mainly for documentation, not for just a byproduct of building the current wall in such a way that it is very useful in documentation. But if you build it in the right way, it can also be used for rendering. And actually, the renderer, when he saw this, he actually wanted to use my image. Unfortunately, I couldn't give it to him because there's no context or anything like that. So this is still in development right now, so I'm still playing around with some of the settings, trying to get more renderings out of it. Now I want to talk a little about rendering from Revit. So as part of sort of like the research I'm doing at Swan is just continue to leverage the model, the Revit model. If it cannot be done in Revit, then what other tools can help it perform the task? So here's some of the tools I looked at. I looked at Autodesk Cloud 360, Indigo rendering, and sort of 360 Max with V-Ray. So the first tool I looked at Autodesk 360 for cloud rendering service. So I took my model, sent it up to the cloud, and gave this rendering back in about 10 minutes, pretty fast. There's another shot. Someone probably came up with sort of rendering to the cloud is that they're limited on sort of the pixel count, so images aren't the highest quality that you would normally get. Next one I checked was Indigo renderer. Now this was an interesting renderer because it had a plugin right into Revit, so I just hit export, shot the model out, and started the rendering automatically. Almost no additional work after that. Of course, you can go into their render engine and tweak sort of lighting, tweak the materials. But I found it very fast to just take the model and just hit a button and just send out the sort of these renderings. Now, the Indigo renderer is sort of similar to Max rendering. Those are familiar with that. Over time, it gets higher and higher quality. So depending on how many times you let it pass, the quality gets a little better. Sort of earlier shot into your lobby. There's just some comparisons between the two. So on the far left is Revit, in the middle is Autodesk 360, and on the right is Indigo. So they have different sort of qualities to them that different renderers are looking for. And then I shot Autodesk 360 at the bottom and Revit on top. And same shot lobby between Revit and Indigo. After I updated the exterior enclosure to a certain level of development, the client wanted more renderings of the project. So instead of the team going back to redraw everything in Rhino, I just exported the Revit model out and they start producing detailed renderings. So these are some of the renderings they were doing in SCA and design. And instead of having them to remodel the entire enclosure, I just gave them my model. And you just sort of see some of the details from the Revit model, sort of joint lines and stack joints. So this sped up the process much faster, since it was already done in Revit once, and it just wanted to render it sort of in the. Since I wasn't responsible for any of the other parts of the project, they weren't quite as well developed. But they knew that Max is already perfect the way they wanted, so they just took my enclosure and put it into their Max model to produce these type of renderings. I'm also exploring sort of going beyond just images. And some of the stuff I'm talking about sort of real-time renderers and interactive environments. So some of the real-time renderers include Lumion 3D. Their program basically is if you drop your model in there, you'll have an almost instantly rendered project as you walk around. So you can zoom, pan, and orbit around, and the project will be 90% rendered perfectly. Now, I've had some, I'm not showing any images of some projects, but I've had some difficulty getting sort of our scope of project in there, so still working that out. I found some of these images online on the Lumion forum. This is actually a Revit project someone did and brought it to Lumion. And of course, I really know it's a classical Revit sample project. Another one I'm looking at is Twinmotion. They also claim the same thing in the real-time renderers. if you look at this one image on the left is rendered in 6 hours in the different render program, and the one on the right in twin motion is rendered in 1 second. So their claim is that they use real-time renderings instantly. So you drop your model in, you set up materials, and whatever you pick, it will already be rendered. If you go to the website, they have a pretty cool video of a space that was completed in twin motion and finished construction, and they had a team go through the space, record the space in live and in rendering. And when I first saw it, I could barely tell which one was the live, which was the rendering. So they showed me. So, some of the shots, like they said, this rendering time took less than half a second. So it's the mean. I'm not quite sure how long they spent prepping the model for this, but I think the effort might be well worth it. If it's pretty straightforward. The last part I want to talk about is interactive environments. So I'm not sure if everyone's familiar with Unity 3D. It's a gaming environment. A lot of games sort of on the latest gaming consoles have it. Websites also use it. So it's also mobile phones. So I took one of the models that you've been looking at into Unity, and you see I can sort of just pan around and I can sort of walk around my space, sort of explore different avenues of the project that you normally wouldn't see.
Can you maximize it?
That's just a little bit. I have it a little bit lower res so that I can do operate a little bit smoother. The great thing about this is that you can now program the world around you. So I've seen many applications where you can walk up to a wall, click on the wall, and you can change the finish of the wall. You can see different design options right there live. Change different parts. For me, one of the things I wanted to see was the roof. And since I don't want to climb all the stairs in the model, I sort of gave myself a little teleportation path. So now I'm on the roof project. So if you look down in the project, there is gravity, so if you do jump out, you do fall down. You don't die though, so it's all right. So here's one of the terraces they have. So I made all the doors so you can walk through them. You can also animate doors where you walk through and you click a button and the door will open eventually, or the door slides. There's a lot you can do with an interactive environment. So I'll just explore some what you can do with this. And I'm still working on the workflow issue. Like I said, Revit model tends to be very, very heavy. So for an engine like this, game engines usually tends to do kind of low poly count models, and Revit tends to produce a high poly count model. One of the things I'm exploring here is sort of 3D environments. So they have a product called Oculus Rift. So we go over your head and it's like you're sort of in virtual reality. And Unity now supports that, so that's my sort of next steps to see how you can use that to inform more design, maybe do a client presentation, and the client can walk through this space however you want to. And that's all I have.
How about some questions? You want to start? Okay, I'll start. In terms of sort of pre-processing and setting up the lighting and the materials, what kind of effort is going into that?
So the question was how much effort goes into applying materials and setting the renders, lighting it out. Really depends on how you set the model. So I think me and Alfred had sort of similar theories that we build a model like it's being constructed, so that way we can also render it as well. So all the materials are applied to the light faces so that we can then tag maybe.
So elevation supply, you want to tag those materials already there?
Yeah, I think some of it you can bring from previous projects because it's the materials transfer from project to project. So it's as much setup as it would be probably if you had you were setting it up in Max. And oftentimes I think right now, the interoperability, you might be able to take some of the materials from 3D Max and bring them into Revit.
How much effort did you put in, or the lighting specifically? Do you have to make fake lights or adjust the real lumens? You make a work set for fake lightery, or you just do good to go? And
For me, most of the renderings that I've done, there aren't any fake lights. They're what it is. But what I guess the only artificial thing we do is that in Revit, when you render it'll, like for example in this view you see here, it'll be really dim. And what you would do is you would spike up the exposure value to get that sort of to get probably the back to be a little more bright, a little brighter. But that's sort of the only.
So you're fully relying on the real lighting, no like 3D
I
Max
do that
stuff.
Yeah.
I do that. I just up the lumens on this particular one just to get the initial conflict. Since the lighting wouldn't be used for anything else, just sort of at the end of the project, towards the end, when they were putting the light fixtures in, they just thought, just give it a try. So,
But I mean that's if I have like the ICS file, I'm using that as like as a measure. But if I'm doing it myself, then yeah, I can set it wherever I like.
Alfred, at the time you were doing those early projects, 2004 through maybe 2008 or 9, there was a lot of skepticism around about Revit. And people were telling you, they were telling me, it's never going to work. Do you feel vindicated? 'Cause I do. I feel that Revit has won.
I think a big part of it, I think that sort of helped me sort of move quicker in terms of learning about it was that I was working, I think, separately from everybody in a way, because at the time in SLM we had almost like 2 teams battling over the same model. And there was a technical team that was sort of making sure the model was adhering to all the standards and making sure that it was going to be built right, and there was a design team that was constantly pushing design forward and changing design. So I had to, at the time, I had to basically carve out portions of my portions of the building to sort of experiment with. And I realized that when I wasn't working with such a bulky model, that I was experimenting more, I was learning more, I was moving faster. And I think that sort of eventually sort of grew into a way of working around even larger projects. I think at the time we were still early in Revit, and that was even before I think linking. And we were just like, the entire World Trade Center project was on one model. And that was really, really heavy. So I think a lot of the tools with the linking and stuff sort of came out of, I guess, our failures.
I was there for the first link. It happened somewhere around midnight on like a Tuesday.
I mean, for me, when they told me that I was tasked to document the closure for this model, I took it as an opportunity to push what Revit can give us. And so I always knew Revit can give us so much more. It's just that opportunity, sort of timing, whether I can get to it. So in this project, even though it was a short schedule, extremely short, small staff, 3 people maybe per project, I took the additional time. I mean, a lot of late nights to push through it, but then once I got this far, any changes down the line that the client made, it was extremely fast for me to adjust my documentation right after. So I think that, if you approach your model in the sort of right mindset, you can definitely get a lot more out of it. So.
I think once you have a good model, you'll ask yourself the questions of like, why does your document look like an AutoCAD set? You'll start putting in other things. It shouldn't look like just an AutoCAD set. You should have 3D views and everything.
The documents at Obsidian Tower, which you didn't show that much of, was a beautiful set of drawings that they weren't CDs, but because it had a script of the 3D views were with the materials and the tags that automatically updated every time they changed the materials, you could build from it. It was really a gorgeous set of detailed design development plus type drawings. And what Alfred hasn't mentioned is that they actually finished early. I was in the meeting when Alfred told the project manager that this little team that had a short schedule finished, I think it was 6 weeks early. It was
Oh yeah, we still had some details to refine.
you
things like that,
found
yeah.
things to do basically, but it was an amazing effort that really proved what you could do in working with the model and making it more efficient, making the whole process more efficient.
I still show them today.
Yeah, 5 years later, it's still a great set and a great way to demonstrate the process. Any parting thoughts before we wrap up? Last questions?
It's usually online questions.
Online questions? Yeah. They probably gave it after they couldn't hear the first 10 minutes.
Yes.
One question, how many people have on your team for the office building? For the office building, I was doing the enclosure and we had 2 other people working on the rest of the building, core shell and interiors. So 3 people total.
Originally it was 5 people.
The files, my material is changed in one file, material is not uploaded, updated. How do you guys get projects? So for my project, the way I built the current wall, everything was done in one file. So that's what typically breaks out the extra enclosure and makes it into the interior model. Both projects that I worked on were actually all in one model. So with the way I built the panels, were very efficient, and I didn't need a separate model for it.
But you can also, because of, if it's linked model, you can transfer the materials between projects and just overwrite and go update.
There's some techniques to create materials in Revit that show up correctly in views. This is probably where the most frustration comes in, is working with Revit material library. Some of the range I do is Revit 2012. Revit 2012 is pretty simple. You build your line, JPEG, like if you do a tile pattern, they allow you to do a lot of JPEG with sort of the representation in drawings. Office tower living 2013, they completely changed the material setup of that, so that's where I frustrating how to get the right material in, the right scale, and the right alignment. So I don't know if Alfred had any better luck than I did.
Good materials are show up correctly. But I had similar frustrations. I think if I get to a point where I just don't think it's actually right, oftentimes sometimes I would see if I can even just put it in. Then you go into Photoshop or something like that. I think sometimes that's just the way you get around it.
Yeah, I think you sort of pick your balance. Assuming third question. The link file updates would not upload the material exists on the other file, they don't update. Is there any way to keep this updated without using transfer standards that you were mentioning?